Okay, so I have the Volvo G976 motor grader in the shop here today, and we're just going to be looking around the implement hydraulic system and steering and cross-referencing components on the machine, learning what they're called, and then also looking at this machine schematic and seeing what things look like on the schematic versus what they look like on the machine. So I'm just going to take a basic walk around first. I'll start in the pump compartment. So this machine's got diesel engine sitting in here. The engine is reverse mounted, I guess we would say. You know, the fan it's mounted like it would be in a wheel loader. The fan is facing the rear of the machine. The flywheel housing is back towards the cab of the machine. And then on the flywheel end of the engine, there is a big power takeoff unit. A lot of power comes off this engine and goes a lot of different places. There's a whole bunch of pumps here, but the power also has to flow from the engine through to the transmission. We got our drive line, mechanical drive to the rear wheels. So there's a transmission, plus there's a bunch of hydraulics. And then the front wheels are driven hydrostatically. So we'll just sort of touch on looking where the hydrostatic components are, but we're going to spend the majority of our time on the implement hydraulics. So right in here, off the power takeoff unit, we've got quite a large axial piston pump. So that's going to be our main hydraulic pump for the implements and steering. And that's where it lives. We've also got hydrostatic pump here, again, for the all-wheel drive system. We're not going to pay too much attention to that, but realize there is a whole bunch of pumps coming off here. And then here we've got a pump for the hydraulically driven fan. So it's got a dedicated pump for turning the fan that moves the air through all the different radiators at the back. Let's go around the other side. So looking at that same pump from here on the left side of the machine, we dig in the pump compartment. We can see everything's buried in a mess of hoses here. But back there, you can see the implement and steering pump says Volvo on it. So it is right there. See the big circular cover on the front of the pump. On the bottom of the pump, here with the yellow and green caps, is the pump control, which has a pressure limiting compensator with the yellow cap on it and a load sense regulator with the green cap on it. Well, this is a load sensing hydraulic system, and we've got the load sensing and pressure limiting controls on the pump. Another hydrostatic drive pump for the left front wheel for its closed loop hydrostatic circuit. And then there's a transmission charge pump here for the 11-speed transmission. And then above the pumps, we've got the main hydraulic tank, the only hydraulic tank. So that's the reservoir for both hydraulic and hydrostatic drive systems. And it is, again, a flooded inlet to the pumps. The pumps are all right underneath the tank, so we don't have to worry too much about cavitation. See, we've got some fairly large suction lines heading in, and fairly old and weathered suction line. And then just moving out to some implements to get a general look around the machine. We've got the circle here, and the circle has the mold board on the bottom. That's what they call the blade on the grader. So the mold board mounts down here. It hangs below the circle. The circle has two lift cylinders that control its height, one on either side, and those are independently controlled by the operator, so they can lift one side or the other or both together and raise and lower the circle. And then the circle has the blade mounted on it. The blade slides left to right, what they call side shift, or sometimes slide shift, depending on when you're looking in the parts book or the service manual. And then the blade also has these two tilt cylinders on it that can tilt the blade. See the other one, we get around the other side. So that's the mold board in the circle. So it's lifted and lowered hydraulically, and tilted and side shifted hydraulically. And then we got circle turn cylinders here. They rotate a couple of gears underneath here. So go underneath this unit. You can see there's some very crude looking gears under here that turn the circle. And this one actually is that's most visible, is actually not a gear turning the circle, that's a gear turning the rotary distributor, or what they call the circle turn valve in Volvo terminology. So we'll get into that system eventually. But that's how the circle is turned. And then we've got some hoses running through the front frame here, down to the front. One of the functions that's hydraulic is the wheel lean. So the geometry of the front wheels can lean this way or this way, so the operator can offset the machine on a side slope, so the front of the machine is not trying to slide down the hill and keep the tread of the tires in contact with the earth. So there's wheel lean. Our schematic's only going to show one wheel lean cylinder because this is a prototype machine. It seems to have two connected, and I don't know why, because they're connected here by a link, but that's the lean function for the wheel, so wheel lean. And then we've got hydraulic steering, obviously. Machine steered over. So there are hydraulic steering cylinders down here, and they have sort of a crossover design on the hoses. One's pulling, one's pushing, but there are two steering cylinders. There's the right side one. We'll walk around the back of the machine, we'll get a better look at how they mount. So the right steering cylinder and left steering cylinder. And again, the hose is crisscross. The hose coming into the head end of the left steering cylinder goes right through the head end, comes out another fitting, crosses over to the rod end of the right steering cylinder. So as the left steering cylinder is extending, it's also putting oil into the rod end of the right cylinder to retract it. And then for steering the other way, this hose comes down into the head end of this cylinder and crosses over to the opposite steering cylinder. So there's always one pushing, one pulling. And that's pretty common when you have two double-acting unbalanced cylinders doing steering on any machine, whether it's an articulated wheel loader or the front end of a machine like this. It's just a common way of getting more power for the steering. So these hoses come out of a bulkhead here at the front of this frame. So that's how they connect the steering lines. They also connect the lines for the wheel lean, same way from that manifold. And then there's also hoses coming out of the front of the frame here, and these are for the hydrostatic drive motor. So again, we've got a hydrostatic drive system that we're not going to be covering particularly this week, but there is a wheel motor, hydrostatic, and a wheel motor on the other side. That's hydrostatic drive fed from hoses mounted in a similar fashion on the other side. So this is a 6-wheel drive machine, mechanical drive through a transmission and drive line to the tandems at the back mechanically, and then we've got drive for the front wheels. It's done hydrostatically. It's really the only practical way to get drive propulsion up to the front would be hydrostatic. Can't really bring a drive shaft or anything up here. So there's that side shift cylinder that slides the mold board back and forth in its carriage, and here's the other tilt cylinder on this side. So we can tilt the mold board, and then we can slide it back and forth hydraulically. And there's also a cylinder here for offsetting the circle from the saddle in the center here, so we can push the circle hydraulically or pull it and move it laterally from its center alignment position in the frame. There's also a hydraulic pin puller here. The operator can pull the pin out of the saddle hydraulically, and that just gives them a larger range of motion in moving the whole circle and mold board around. You can actually pick this whole assembly up and turn it right on its side and theoretically grade the side of a cliff. Back in here behind the cab, sort of under where we looked at the pumps, there's also articulation cylinders for steering. So this machine steers two ways. It's articulating, there's a front frame and a rear frame, and the machine will articulate with those cylinders. And then we've also got steerable wheels, so we can articulate the machine one way and then offset the steering at the front another way and make this machine into quite a pretzel if we know what we're doing. The control valve for all of those functions we just discussed is normally under a cover, but we've removed the cover here and it's in front of the cab. It has to be right in front of the cab because it's all mechanically operated. So we've got only mechanical linkage coming in here. You can see the linkage on the bottom. See the levers moving inside the cab. So this is called the 10-bank valve because there's 10 sections to it. And it is a closed center valve and it is load sensing. There's a hydraulic oil cooler back here. That's one of the radiators that the main fan pushes air through. The fan's kind of arranged in a box back here. And then back here we've got an axial piston motor. So there's a big piston motor here that drives the big fan, and that's going to move airflow through all the radiators. So this box at the back, I've just swung the fan assembly out on a hinge. In here they give us access to clean all of our cores. Again, we've got an hydraulic oil cooler. Got, I believe that's the engine rad, air-to-air aftercooler and air conditioning. And then down at the bottom, I think, is the transmission oil cooler. So lots of cores back here, all cooled by this fan. And this is a variable speed fan, as we'll see, and it's also reversible. So it's one of the benefits of having a hydraulically driven fan is we can flip a valve and rotate the fan the opposite way to purge debris out of the rads. In the left side compartment here, we just get another look at the back side of the tank, and we can see how some of the lines come from the tank for suction for various pumps and return. And then we can also see this unit. We've got another pump under here, an aluminum gear pump driven by an electric motor, and this is part of our supplemental steering system. Supplemental steering is an emergency steering system that will kick in if we lose supply from the main pump feeding the steering unit. Let's go up in the cab and look at some valves. So this this grader has got this type of a helm in it. The industry's gone back and forth between joysticks and this type of control, but again, we've got mechanical linkage. So we've got all these linkages running down through the helm, through, out, and back up to the 10-bank valve that's across the front of the cab. So we've got a separate lever for every function, and I believe 9 of the 10 of them are used on this machine. There's one option that is empty. And then we've also got hydraulic steering. So again, if we were to lose our supply from the main pump that feeds the steering control, which you can see just out in front of the cab here, that valve right there is our steering control valve, rotary control valve. Same one that's in the 310SG that we talked about. Again, closed center load sensing steering. This time though, instead of working with a gear pump like it did on the 310SG, first of all, we could see this one when we take the cover off. Couldn't see the one on the 310. And then it's running from a piston pump, as are all the hydraulics. So all the hydraulics we've looked at, other than the hydrostatic drive components, all the implement controls, including articulating steering and main steering, are all fed from that one big axial piston pump that we saw. What we won't see on our hydraulic schematic or part of the hydraulics is the brakes. Unlike a lot of modern machines, this machine, the brakes are more a master-slave type, almost like a truck, but they're a boosted master-slave system, but they use their own fluid reservoir. They don't interact with the implement hydraulics. We've got a control for turning on or off our six-wheel drive, our all-wheel drive for our hydrostatic setup for the front. We've also got an aggression control where we can set how aggressively the front wheels pull in relation to how aggressively the rear wheels are pushing through the conventional drivetrain. There's just another shot of how the linkage connects from the helm controls down through and out and up to the 10-bank valve. So there's our 10-bank valve with all the functions. We could follow all these hoses and trace them to the various cylinders. And because it's a load sensing system, this hose, a small hose coming off of the valve, is bringing the load sense signal out of the 10-bank valve and sending it towards our load sensing pump. So that hose disappears underneath the cab, and it ultimately comes out and comes into the control where we've got the green cap on that pump. So this valve is made by a company called Husco. They make a lot of valves for, John Deere uses them a lot, Volvo obviously uses them. Very popular series of directional control valve, and especially on load sensing closed center systems. We'll see this one a lot. The pump, however, is not Husco. The pump is Rexroth, which again is a very common manufacturer of pumps in load sensing systems. Now I'm just underneath the machine on a creeper here, and there's the back of our rear differential assembly that's going into the tandem units, just for perspective. And if I come around on the front here, I'm going to see the priority valve. So that's our Eaton brand priority valve, which we've looked at in our priority valve video. And we've got some of these on the bench we can take apart. But that's where our priority valve lives. Kind of an odd location. Underneath the engine here, there's the oil pan of the engine. And there's a brace that goes across on the frame. And that's where the priority valve is. Also, under here I can see the fan control for our variable speed and reversible fan. That's cooling all the radiators. The hydraulically driven fan motor is fed from this valve between the pump and the valve. There's this valve that does the reversing, and it's mounted down here as well.